This is our classifying chemical reactions, analyzing and predicting products lab. There are kind of 7 separate experiments in this lab, and so I'll go through each one, not necessarily in the exact order because some reactions take longer than others. And so we're going to start with reaction 4 first. From experience, I know this one takes a bit more time. So our reactants in this experiment are copper 2 chloride, which looks like this. It is a clear solution, but it is colored with that bright blue colored. And our second reactant is zinc metal solid. So I have some here in this tray, zinc metal solid. It is shiny and silvery colored, like many metals are. And if I poke at it with a spatula, it's pretty hard. I can't bend it or anything like that. So those are the properties of the zinc. So what I'm going to do, I'm not going to do the exact measurements in the lab because I need to have enough in the test tube for it to actually be visible for you playing at home. So here is, I've put a couple mils of the copper 2 chloride in the test tube, and now I'm going to add the zinc solid to it. Not very exciting. Maybe it'll get more exciting later on. I'm going to set this one down for now, and we'll come back and revisit it later. Next, we're going to look at experiment 1. Experiment 1, the reaction is actually already going on here. I have lit the Bunsen burner. The Bunsen burner is fueled by carbon tetrahydride, CH4. It's the flammable gas that's being burned right now. So it's colorless. You can't see it when it comes out of the tap. You can smell it, so it has a smell. But I don't smell anything right now because all of my methane gas, all of my carbon tetrahydride gas is burning, and I don't actually have any of that CH4 left anymore. So it's reacting with something in the air. The air around us is also colorless. It's reacting with something in the air that's causing it to burn. And you should know what gas in the air it is reacting with because you did your background reading, and you know that burning is a particular kind of chemical reaction that involves an element that you find in air. So this is a reaction of 2 colorless gases, and there are products to this reaction. We can see that a chemical reaction is going on because we see a light is being given off, and I can feel heat being given off as well. So we have a couple of signs that a chemical reaction is going on. And what I'm going to do is I'm going to take a clean, dry test tube that's, kind of at room temperature. This first observation I want you to make happens quite quickly. One more time. Okay, I think the test tube is actually getting too hot to be able to make that observation anymore. I'm going to switch to another cool test tube. I hope you see that the test tube actually gets foggy. There's kind of a fogginess going on inside the test tube. When the test tube is still cold, I'm actually getting little condensation droplets forming inside the test tube. I'll try this one more time. Nope, too hot again. Okay. You can kind of see the cloudiness briefly in there. So you're actually getting kind of condensation droplets briefly inside the test tube, especially when the test tube is cold. Again, from reading your pre-lab, you should know what gas produces that cloudiness, that condensation, those little droplets inside of a cold test tube. We're still on reaction number 1. We've made an observation about one product that was given off. I'm going to test for another gas now. I'm going to just collect any gas that's given off by this chemical reaction going on right now. I'm collecting the gas in the test tube, and I'm going to light the splint so that it's on fire, and I'm going to put the lit splint into the test tube, not all the way down, just enough inside. And I don't have to go very far inside the test tube to extinguish the flame. So whatever gas is inside this test tube extinguishes a lit splint. Again, from your pre-lab, you should have a sense of what gas would cause a lit splint to extinguish. Now, as you're watching this reaction, notice you don't actually see anything being given off. We've just done tests for 2 gases, but you don't see those gases. Those gases are clear and they're colorless. The next reaction we're going to do is reaction 2, where we take a strip of magnesium metal ribbon, and here you can see magnesium metal is a silvery colored shiny metal, and you can see that it's malleable, it's bendable, because this piece is bent. It came as a nice straight ribbon, so it does change its shape. It's pretty flexible. I'm going to light this in the Bunsen burner. Now, on a video recording, you're not going to have to worry about the brightness, but if you were looking at this in person, you would not want to look straight at the bright light, because it does release UV light, which isn't good for your eyes. And now that that has burned, I'm going to drop it into a crucible dish so we can examine the properties using spatula. So here I have an intact piece of magnesium metal, just for comparison. You can see it's solid. When I poke at it, nothing happens. And there's a bit of unburned magnesium here, but this burned magnesium, when I poke at it, crushes. It's very brittle, very fragile. It crushes into pieces very easily when I poke at it. You can see it's white in color. Mostly white in color. There is a little bit of soot here. That's soot from the flame, but the pure product over here is white in color. So it looked like it was still a piece of ribbon at first, but although a different color, but when I started poking at it, it clearly had different properties to the original magnesium metal, which doesn't break at all when I poke at it. Experiment 3 also involves magnesium metal, but this time we're going to react it with hydrochloric acid. Hydrochloric acid is, let me hold it up to the camera. It is a clear and colorless solution. It looks like water. It definitely isn't water, but it looks like water. And the magnesium metal looks the same as before. It is a silvery colored shiny metal. This time I've curled it into a curly Q shape so that it'll actually all be submerged in the hydrochloric acid. So I'm just going to add this to the hydrochloric acid. And because I can see bubbles being released, I'm going to get a cork to try to trap any gases that are being given off here, because I want to do a test to determine what gases are being given off. So you can see this is quite a vigorous reaction going on, lots of bubbles. And if I feel the test tube, I can feel that it's warmer than it was when I started. So definitely feel some heat. I can definitely see the bubbles. I can actually hear them as well, although it's difficult to hear over the sound of the Bunsen burner. I am keeping the Bunsen burner on though, because I need it for to test for a gas. So I'm gonna light a splint and put the lit splint into the open end of the test tube, and we'll see if we can determine what gas is being released. So that was a squeaky pop noise, which is standard for a particular gas. Again, from your background information section, you should know what gas makes that squeaky pop noise when a lit splint is brought nearby. Now, we will need to kind of see how this looks when the reaction is finished, because right now there are so many bubbles, I can't even see. I don't know if the liquid is now white or if it's just white because of all the bubbles happening in it. So I'm going to set it to the side and we'll look at reaction 3 later. We're back to reaction 4. We've done a few experiments now, and you can see we started with a metal that looked like silver. It was shiny and that kind of gray color. This is clearly not shiny and gray colored anymore. Also, the liquid we started off was a really beautiful, intense blue turquoisey color. And that turquoise color seems to be not so turquoisey anymore. And if you compare the before turquoise color to the after turquoise color, there's definitely less blue there. So I'm kind of seeing 2 color changes. I'm seeing a change in the blueness, and I'm seeing a change in the color of the solid at the bottom. I'm going to pour this out into an evaporating dish so that I can kind of poke and prod at it and see if any other changes have happened. So I can definitely see that the blue color is less blue, and this solid, it's this brown color, and I seem to be able to definitely this texture is different from before. This was a very solid piece of metal before. I still have a solid piece of metal here, but this just seems a bit more flaky. So be sure to record your observations there for experiment 4. Next, we'll do reaction 5. I'm going to be using calcium chloride and adding that to my test tube first. This is another solution that looks like water. It's clear, it's colorless. It is not water. I mean, it is a solution. It does contain water, but that's not the only substance there. And now to this substance, I'm going to add some sodium phosphate solution. Now, it's not immediately obvious. It does seem to be changing color. It looks a little cloudier than it did before. It doesn't look totally clear like water does. Also, it just kind of feels a little chunky, like when I'm dripping additional sodium phosphate into the container, it's not splashing as much as I'm expecting to. It's acting almost like a gel. So I will set that aside for a moment, see if it looks any different after a couple more minutes, but that is my reaction 5. In case it wasn't obvious, this sodium phosphate is also a clear and colorless solution that looks like water. Reaction 6 involves sodium hydroxide. So I'm going to add some sodium hydroxide, which again looks like water. It's clear, it's colorless, it's my sodium hydroxide. And I'm going to add some phenolphthalein indicator, which is also clear and colorless. Just add a couple drops of that. And you can see, even though I mixed two clear and colorless solutions together, it is definitely not clear and colorless now. I'm going to take another clear and colorless solution. Hydrochloric acid is also clear and colorless. And I'm going to add it to this test tube and see if any changes happen. So it doesn't seem to be doing much. I don't know, I'll keep on going. Huh. Now if you can see this, the pink seems to be disappearing from the top. If I shake it up a bit, I made the pink totally disappear. So that was 3 colorless solutions. Mixing 2 of them together turned pink, but mixing the 3rd one in made it go clear again. Interesting. Reaction 7. Reaction 7, I'm going to add calcium chloride to a clean test tube, and calcium chloride again is one of these clear and colorless solutions. Looks like water. Now, the next substance I am going to add is also clear and colorless, but it's light sensitive, so we keep it in a dark bottle so that the light doesn't affect it so much. And so you can see inside the droplet, it is clear and colorless like water. So 2 clear and colorless solutions. And I'm gonna add, even just 1 drop made a noticeable difference there. I'll add another drop. Yeah, definitely, that's definitely not a liquid in there. Definitely acting like solid chunks of material. Even just adding 1 drop of the silver nitrate. So that's reaction 7. Let's go back and look at other ones that we said we were going to check back in on. Reaction 3 here has finally died down. There are still a couple bubbles I can see there, but I can tell now that the liquid here is definitely not white. It's definitely clear and colorless like water. I still see some bubbles stuck to the side, but I can kind of shake those away. Looks like I've got some magnesium metal left over. It still looks like magnesium metal. It's silver, it's shiny. But obviously some sort of chemical reaction happened. It looks like there's just some magnesium metal left over. We already looked at experiment 4. Experiment 5, I don't know, still looks the same. We've got that cloudy white precipitate that's formed. Reaction 6 hasn't had any further changes of color. And Reaction 7 still has that white chunky precipitate in the bottom. I hope this helped.